welcome back to part 2 of Powers of Monomials. This is chapter 4, lesson 3. Just had some very spicy Kaneka sausage, so you may hear me sniff a little bit because my mouth is still on fire and my sinuses are still a little Power of a product property states in words, and this is a vocab term, to find the power of a product, find the power of each factor and then multiply. What does that look like in algebra? A times b to the mth power is going to be a to the m times b to the m. And if you're using numbers, 2x cubed to the 4th power means you're going to take 2 to the 4th power and you're going to take x cubed to the 4th power. And of course, 2 to the 4th power is going to be 16. And then x cubed to the 4th power, that's 3 times 4, that's going to be 12. Of course, this is not going to be enough to count for showing your work, but we're going to show you what will be. And here we have example 3 where we're going to demonstrate the power of a product. The problem says 2p, where the p is going to be cubed, and the whole problem, 2p cubed, is going to be raised again to the 4th power. And you're going to find this is just as easy to do as everything else. We're just going to spread things out a little bit more. So moving through our steps, the next thing we did is we distributed this 4 through the grouping symbol. So now you have 2 to the 4th power that you see right here, and you have p cubed to the 4th power that you see right here. From there, we're going to take and say that means 2 to the 4th times p cubed times 4, where we took this and used the power of a power property. Of course, 3 times 4 is going to equal to 12. 2 to the 4th power, that's 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So you're going to have 16p to the 12th power. This is showing your work. This is what I must see. If I see anything else, you will have done it just for fun. And if you want to get a warm fuzzy feeling, go ahead and type in that answer that they just showed us, and it'll give you that happy dinging sound. Now our textbook asks a good question. It says, why was the exponent 4 applied to both of the factors in the step down? Well, the 4 is outside the parentheses. That means we have to apply that 4 to everything inside the parentheses. And now it's going to be your turn. Pause the video, solve this problem on your own. Make sure you're giving good quality supporting work just like I've been showing you so that you can get credit for it on your homework. Did you get the happy ding sound? Let's see how I do this. So I'm going to start off with the original problem here. Put in my equal sign, and then I'm going to distribute that 2 through the grouping symbol. So I'm going to have 8 squared times b to the 9th squared. From there I can say 8 squared times b to the 9th times 2. 8 squared is going to end up giving me 8 times 8, which is going to be 64. And then b to the 9th squared, that's going to be b. 9 times 2 is 18, for the final answer of 64, b to the 18th power. Help make that b a little bit more b-like. So we're going to come over here, type in our answer, 64b exponent 18, accept and check, and the answer checks. Very easy to do this stuff, but you do need to make sure you're showing the supporting work just like I'm showing to you right here. But what if you had a whole bunch of pieces parts inside your parentheses just like we have this one? Well, it's going to work the same exact way, only we're going to distribute that 5 through the -2, the m to the 7th, and the n to the 6th. Every piece is going to get it. You do need to be careful with that -2 though. The whole thing, -2, is going to be raised to the 5th power, so the whole thing is going to end up having to go inside your parentheses just like we've done in other occasions. So this here right here is how it's going to work for you. You know it's a -2. We put in parentheses, raised to the 5th power. The m to the 7th became n to the 7th, raised to the 5th power. The n to the 6th became n to the 6th, raised to the 5th power. From there, we can say -2 times -2 is +4. +4 times -2 is -8. Negative 8 times negative 2 is positive 16, and positive 16 times negative 2, there's my fifth one, that's going to be a negative 32. M to the 7 times 5 is going to be m to the 35th, and then n to the 6 times 5 is going to be n to the 30th. It would be good to put a little step in there showing how you're multiplying all that out. And if you want that warm fuzzy, go ahead and put the answer they gave you right here, and it'll make that happy tone for you. And now it's going to be your turn to pause the video again and work this problem. It's going to be just a little bit bigger than the last one you did, but I am totally confident you can work it out. So let's take a look at how I would work this problem. I would start out with my equal sign here. We'll need a pen to do that. Got my equal sign. I'm going to distribute the 4 through my grouping symbol. So I'm going to have 6 to the 4th. Don't need parentheses on it because there's no negative sign. Times x to the 5th power raised to the 4th times y to the 11th power raised to the 4th. From there, 6 to the 4th, well, I'm going to go ahead and work that out just so I don't have to keep doing that. 6 times 6 is going to be 36. 36 times 6, that's going to be 180 plus 36 again. Nope. Plus 36 again is going to be 216. And 216 times 6, well, that gets a little bit harder. So how about we just go ahead and do this. 6, y to the x, 6 again. And that tells, I'm sorry, I did the wrong thing. 6 y to the x 4, and that gives us 1,212. So I have 1,200, actually 296, which is going to go right here. X to the 5th times 4, y to the 11th times 4, and when you take and finish it up, you get 1,296. X 5 times 4 is going to be the 20th. Y 11 times 4 is going to be 44, and that is going to end up being your final answer. Jump over here. We have two possibilities. We have the 1,296, but only one of them has the right exponents. Answer B is going to be what you're looking for. So let's take a look at a real-world apply problem involving some geometry and powers of monomials.
The floor of the science lab at Davis Middle School is in the shape of a square. The floor has side lengths of 8x cubed y square units. The current floor tile is being replaced with new tile. The new tile is also in the shape of a square with side lengths of xy units. How many tiles will it take to cover the floor?
Well, that does pose quite a challenge, because what we're going to have to do is find out, first off, what the area of that floor is going to be, and then we're going to have to divide it into XY tile sections. So that's going to be quite a bit of work. We're going to go ahead and skip over to the next part where we have the actual problem written, and I'm going to work through this one with you. I'm not going to expect you to know how to do all this on your own. Let's get ourselves a screenshot right here, and paste that into our working slate right here. And let's find some clean real estate here. That looks like a good spot. So right there. And now we're going to start off by finding the area. It is a square, so the formula for the area of a square is going to end up being area is equal to side squared, where the side length is going to be 8x cubed y squared, all squared. Now we can say the area is equal to, distribute that 2 through there, that'll be 8 squared times x cubed squared times y squared squared. Keep working through the problem. Gives us 8. Well, 8 squared is going to give us 64 times x cubed times 2 times y squared times 2. Area is then equal to 64. X 2 times 3 is going to be 6, and y is going to be 2 times 2, which is going to be 4. Now that is not the final answer, it's just an important sub-answer. From here we have to take and divide it into xy units. And that is going to be a little bit trickier, but I'm going to show you how it works. We have covered this before. We're going to take the 64 x to the 6th, y to the 4th, and divide it by xy. Well, when we did that before, what we would have done is 64 x to the 6th minus 1 for this one right here, and y to the 4th minus 1 for this one right here. That means your final answer is going to be 64 x to the 5th, y to the 3rd, and that's what I'm going to put in for my answer. So I'm back on my answer page, and it says, oh, how many tiles will it take? The answer is going to be 64 x, look, that's a C, x to the, what number did we come up with over there? X to the 5th. And then come over down again, y exponent to the 3rd, except, and check, and it did not like my answer. Let's see if I can figure out why. Well, I just figured out why, and the answer is because I got too far ahead of myself. I divided by the wrong thing. I divided by one side length of my square and not the area of the square. So we're going to have to take of the little square tile. So we're going to have to take from there and do a little bit more work. We're going to find the area of x, y, all squared. That would be x squared, y squared if we were to take and use that power over power rule. So from there, we're going to take and divide by x squared, y squared, which means this 6 will be minus 2, that 4 will be minus 2, which is going to give me 64 x to the 4th and y squared for our final answer. Let's come back over here and see if we can get a happier sound. 64 x to the 4th. Whoop, my 64x didn't take. 64x, there we go, and y exponent squared, except, and check, and now we got the right answer. I doubt you're going to see something that hard on your homework, but if you do, you've already seen me make a mistake, so you know what mistake not to make on yours. Get started on your assignment. I look forward to answering any questions you have in class tomorrow.